Imagine you're playing your favorite video game, watching a high-definition movie, or even rendering a 3D model. The stunning visuals, intricate textures, smooth animations, how do all these elements come together in real time? The answer lies in a powerful piece of hardware that resides within your computer, the GPU, or Graphics Processing Unit. While many people are familiar with the term, few fully understand how these devices work or what makes them so essential to modern computing. In this video, we're going to explore how GPUs work, the architecture behind graphics cards, and why they are fundamental to a wide range of industries, from gaming to machine learning and video editing. This is your chance to take a deep dive into the world of GPUs. What is a GPU? A GPU is essentially a specialized processor designed to handle the tasks involved in rendering graphics. Unlike a CPU, Central Processing Unit, which is a general-purpose processor designed to manage a wide variety of tasks, the GPU is built specifically to manage the highly parallelizable workload of creating visuals. The reason for this specialization is simple. Graphics processing requires a lot of calculations, and a lot of them need to happen at the same time. In gaming, for example, the GPU is responsible for rendering the entire 3D world you see on your screen. It calculates how light interacts with objects, handles texture mapping, applies shading, and much more, all at once. Unlike a CPU, which can handle a few complex tasks at once, a GPU is optimized for performing thousands or even millions of simple tasks simultaneously, making it a perfect tool for creating realistic images and video in real time. The key to understanding how a GPU works is understanding parallel processing. While a CPU might have 4 to 16 cores, each of which can perform one task at a time, a GPU can have thousands of smaller cores capable of executing tasks concurrently. This allows the GPU to process large amounts of data much faster than a CPU could in the context of graphics rendering. The architecture of a GPU. Let's break down the architecture of a modern GPU into its core components and understand how each part plays a role in delivering the stunning visuals we enjoy on our screens. 1. CUDA cores, stream processors. The heart of any GPU are its cores, the small processing units that carry out the computations required for rendering images. In NVIDIA GPUs, these cores are known as CUDA cores, and in AMD GPUs, they are referred to as stream processors. These cores are highly parallelized and optimized for the massive number of calculations required to render graphics in real time. For example, in a high-end GPU like the NVIDIA RTX 3090, there are over 10,000 CUDA cores. Each core is capable of performing small operations, like calculating the color of a single pixel or applying a transformation to an object in 3D space. The more CUDA cores a GPU has, the more tasks it can handle simultaneously, resulting in faster and more efficient processing of graphics. The high number of cores allows GPUs to handle highly parallel tasks, such as performing operations on many pixels or processing the geometry of 3D objects all at the same time. 2. VRAM, Video RAM. The GPU has its own memory known as VRAM, which stands for Video RAM. Unlike System RAM, which is shared by the CPU, VRAM is dedicated solely to graphics processing tasks. It stores textures, models, frame buffers, and other data required by the GPU to render images. The amount of VRAM a GPU has is critical to its performance, especially in modern gaming and professional applications. High-resolution textures, complex 3D models, and large video files require a lot of memory. VRAM ensures that the GPU has fast access to the data it needs without having to rely on slower system memory. 3. GPU clock speed. Like CPUs, GPUs also have a clock speed, which is measured in MHz, megahertz, or GHz, gigahertz. The clock speed determines how quickly the GPU can process instructions. The higher the clock speed, the faster the GPU can execute tasks. 4. Shaders. Shaders are programs that run on the GPU to perform specific tasks related to rendering. There are several types of shaders, but the two most commonly discussed are vertex shaders and pixel shaders. Vertex shaders. These shaders process 3D vertices, the basic building blocks of 3D objects, and transform them into the appropriate 2D positions on the screen. They handle transformations such as translation, rotation, and scaling, and apply operations to determine how objects in 3D space will be displayed. Pixel shaders. After the vertices are processed, pixel shaders come into play. These shaders are responsible for calculating the final color of each pixel. They take into account lighting, textures, shadows, and other factors to determine how each pixel should appear in the final image. Pixel shaders help create realistic effects, like reflections, refraction, and shading. Shaders are incredibly powerful and flexible, allowing developers to create complex visual effects by writing custom programs that run on the GPU. 5. Rasterizers. Rasterization is the process of converting 3D objects into 2D pixels that will be displayed on the screen. The rasterizer is the component of the GPU that performs this task. It takes the processed vertices, applies the necessary transformations, and then fills in the pixels that make up the image. How does the GPU render images? Now that we understand the key components of a GPU, let's walk through how it actually renders an image. 1. Vertex processing. The first step in the rendering process is vertex processing. During this stage, the GPU takes 3D data from the CPU, which includes the positions, shapes, and other properties of objects in the scene, and processes them. The vertex shader is responsible for transforming the 3D coordinates of each object based on factors like the camera position, lighting, and any animations that may be applied. The result of this step is a transformed version of the object in 3D space, which is ready for the next stage of rendering. 2. Final image composition. Finally, all the various elements, geometry, textures, lighting, and shading, are combined to form the final image. The GPU then displays the rendered image on your screen, ready for you to view or interact with. Types of GPUs. There are two primary types of graphics processing units. 1. Discrete GPUs. A discrete GPU is a dedicated graphics card that sits in its own slot on the motherboard. Discrete GPUs are powerful, offering a large number of CUDA cores or stream processors, ample VRAM, and robust cooling solutions. These types of GPUs are found in high-end gaming PCs, workstations, and professional-grade laptops. Discrete GPUs excel at rendering complex 3D scenes, running high-definition games, and processing massive data sets. 2. Integrated GPUs. An integrated GPU is built directly into the CPU or motherboard and does not have its own dedicated memory. Integrated GPUs share system RAM with the CPU, which limits their overall performance compared to discrete GPUs. While integrated GPUs are not suitable for demanding tasks like 4K gaming or professional rendering, they are perfectly fine for everyday tasks like web browsing, video playback, and office work. Why are GPUs important? GPUs are not only essential for gaming, they have applications in many other fields. Machine learning. GPUs are heavily used in training machine learning models due to their ability to handle massive amounts of data in parallel. Cryptocurrency mining. GPUs are also used in cryptocurrency mining, where they perform the necessary calculations to validate transactions and create new coins. Video editing and rendering. Professionals in the video production industry use GPUs to speed up the rendering process and enhance playback. In conclusion, the GPU is a powerful, specialized piece of hardware responsible for bringing the digital world to life. Whether you're gaming, editing videos, or training AI models, the GPU's architecture enables it to handle demanding graphical workloads quickly and efficiently. If you've enjoyed learning about how GPUs work and want to dive deeper into the world of technology, be sure to subscribe to TechEase for more detailed explorations. Don't forget to hit the bell icon so you'll be notified whenever we post new videos. Let us know in the comments if you have any questions about GPUs or any other tech topics you'd like us to cover. Thanks for watching, and we'll see you in the next video.